Hey there, and today we're going to be discussing the amazing world of circles, and more specifically, equations between two of them. So first off, what's the point in having equation between circles? And what's the method to do it, and how do we apply it? And we're going to be going over all this, and in the end, we're going to be showing a couple examples of how it can be used. Well, first we are using the system of equations. So, system of equations are equations with the same set of unknowns, and we try to find values that satisfy these equations. So, we usually try to solve for variables, usually x or y, and then we plug it back into the equation to solve for the rest of it. The equation of circles is often expressed as x minus h squared plus y minus k squared equals the radius squared. We're going to be needing this for the system of equations. And the center of the circle is often represented as HK, and R is the radius. So the point is to find the points between two intersecting circles and solve for where they meet using the system of equations, whether it be 1 point, 2 points, and on the right are examples of what these should look like. So the system of equations here, the equation of a circle, and what we're going to be solving for. So for our first example, it's zero intersections, so there wouldn't be an answer for this because at no point do these two circles overlap, so they don't share a coordinate. So we cannot solve for this type of problem. For example 2, we're going to be doing two intersections. Because we're solving for two intersections, we then find the points of where these circles would meet. And we first take the radius of both circles and the equations and put them into a system of equations form. So using the equation we saw in the beginning, you can make your equation. So because I based my first circle A on the origin, it would be x squared plus y squared equals 8 squared, or 8, sorry, and x minus 12 squared plus y squared equals 8 for the second circle. So we set up for the equation and isolate and solve for the variable and then plug it in. So what you do for the first one, what I'd recommend is that you put it in, so y squared equals everything else. And then for the second one, you just FOIL it or expand it. And then you should get x squared minus 24x plus 144 plus y squared is equal to 8. And then since you already know what y squared is here, you just plug that back in. So you substitute it. And then after you're done following and solving, you should get 6 for the answer. So then you take this x value and plug it into this original equation, x squared plus y squared is equal to 8. And you plug it in for the x, and then you should get y is equal to the root of 32 when you're done solving for that. This is both positive and negative because we're trying to solve for these two intersections right here and here. So one would be in the positive and one would be in the negative. So it would still be 6, but the y coordinate would change positive and negatively. So you should get 6 root 32 and 6 negative root 32 for this set of intersecting circles. So for our next example, it's one intersection. Because we're solving for one intersection, we would find the point of where these points would meet, and we take the radius of both circles, and you're basically kind of doing the same thing. The only difference here is that I did not base it around the origin or circle around the origin. The intersection is at the origin. So this is how you would set it up. So x plus 4 squared plus y squared is equal to 16. That would be the smaller circle. And x minus 8 squared plus y squared is equal to 64. That would be this bigger circle. So first what you want to do is you want to set up the equations and expand by foiling. And then after you're done foiling, try to make it into a y equation again. So after you're done with these steps, you get y squared equals x squared plus 8x, and y squared equals x squared minus 16x. And because they're equal to each other, you just set them equal to each other, and you solve for the same variable x. After you're done foiling and solving and whatnot, you should be getting 0 for the answer. And then after this, you plug 0 back into this equation. I just used it because it was easier. And you should be getting y squared is equal to 0. Or technically y squared is equal to the square root of 0, but because you can't take the square root of 0, it just ends up being 0. And we can see it's right because D is on the point 0, 0, which is where they intersect. And then if you want to make a line out of this, it's very simple. At least for the two intersections, you just take the points and then you do points. You can do point slope form. Finding the slope would be very easy for those. It's just what you'd regularly do for any other line. So thanks for listening in, and I hope you enjoyed my video.